Hi there. So after a brief interlude with sectors, we're going to go back to talking about scale a little bit. And this is mostly just because this is the order that it ended up in last year. And I didn't want to have you reorder the pages too much in the packet for those of you who are using it. So get yourself ready for notes, and we are going to talk more about scale. So scale factors can be written as we saw on the maps and the drawings in the lesson earlier this week. They can also be written as ratios like this. And with the scale conversion, you're always going to see the scale and then what it actually is in reality. So for instance, if I'm looking in number 1, determine if the scale enlarges or reduces the size of an actual object. So the scale is what it appears to look like. So in this case, it appears to be 10 feet and it's actually 24 inches. Now what this means is, since we know that, hopefully we know that 10 feet is greater than 24 inches, that means that the scale is bigger. So the drawing, the map is bigger than the actual object. So what that means is that it enlarges it. And sometimes we would definitely want to enlarge the scale of things. We're sort of used to thinking about maps where we're shrinking something down, like the map of the United States fitting on a piece of paper. But we also do a lot of things with enlarging things, such as looking at things in a microscope. That would be a perfect example of something enlarging. Now here, we've got 6 centimeters and 600 meters. And this is one of those cases that's like, oh, I don't remember exactly which way it goes. So one thing that can be really helpful with scale is converting them to the same unit. So in this case, you're like, okay, well, we've got scale in meters. I do remember that it goes this way to turn into centimeters, 2 spaces. So this becomes 6 centimeters to 600, 2 more zeros, so 60,000 centimeters. And then you don't have to guess. You can say, oh, okay, well, this is definitely going to be 60,000 of something is much bigger than 6 of the same thing. So then what that means here is that the scale is smaller. And then we say that therefore the scale reduces the size of the actual object. For number 2, fill in the blank so that the scale preserves the size of the object. Now, when it says the scale preserves the size of the object, that means it keeps them the same. Keeps size the same. So what that means is we want the scale factor to be equal. And this just means that it's a life-size drawing of something. So in this case, we have 1 yard is equal to blank inches. So we can just use our conversion here. Some of you might do this in your head. Some of you might want to do this on paper. I will do it written out so that we can practice. So 1 yard, we put that over 1. And then we want to change from yard to inches. Maybe you don't know what that number is right away. So then you say, I'm going to change it to feet first, which I do remember, and then from feet then to inches, so that our units cancel. And we're left with just inches, which is what we want. Now we need to fill in the numbers. 1 yard is equal to 3 feet. 1 foot is equal to 12 inches. So you get 1 times 3 times 12 over 1 in the denominator, inches. So 1 yard to 36 inches would preserve the scale, would keep it equal. So you might see conversions like this written as a ratio. You might also see the scale factor. Now if you think about conversion factor that we just used, what that means is we're going to write it as a fraction instead of a ratio, with the scale in the numerator and then the actual size will be in the denominator. So a model has a scale conversion of 6 centimeters to 600 meters. Find the scale factor. So this is the example from part B above, but now we want to write it as a factor. So we've got 6 centimeters to 600 meters. So again, scale in the numerator is the same as scale first. Now, just like we saw in our previous lesson, we want to convert it to the same unit. So we are going to write the numerator as 60 1,000 centimeters, just like we did before, 6 centimeters. And now we know we are on the right track because those will cancel. We're simplifying our fraction. We can also simplify our fraction, divide by 6 on both sides. And so you end up with 10,000 in the denominator and 1. So the scale factor would be 1/10,000th. Number 4, an architect builds a house with a model of a house with a scale of 0.5 inches to 15 feet. Find the scale factor. So again, set the scale in the numerator, so 0.5 inches over 15 feet. They're not the same unit, so we want to convert. I'm going to turn them both into inches in this case, so multiply feet by 12. And I end up with 180 inches in the denominator and 0.5 inches in the numerator. Now I want whole numbers to simplify my fraction. You can't leave decimals in a fraction, so I'll move that space over and I end up with 5 over 1,800. The inches cancel out. And now I can just divide both by 5. So I end up with 1 over 360 as my scale factor. Now we can also solve with this. So if the first floor is 12 feet high in the house, how tall is it in the scale model? So I'm actually going to solve this very similarly to what I did with the map. And I'm going to say, well, my scale factor is 0.5 inches to 15 feet. Sorry, not my scale factor, my scale conversion. And I have something that's 12 feet in the actual house. And so then that is how tall. And this is my unknown, so I will put in the variable. Now I know I'm off to the right start because my units all cancel out. And then I'll just write this as a proportion. So I have 0.5 over x is equal to 15 over 12. I'm going to simplify my fraction here, and that's going to be simplified by 3, so I end up with 5 over 4. And then when I cross multiply, I end up with 5x times 0.5 times 4. So 5 times x equals 0.5 times 4. Meaning 5x is equal to 2. Divide both by 5. And the height in the model, which is x, we could write as 2/5 of an inch, or if you wanted to express it as a decimal, 0.4 inches. If you have questions about scale, in any of these cases or about sectors, please let me know, and I'll be happy to help you either by nominating problems in the form attached or leave me a comment, send me an email.